go ahead before we do anything, and let's go ahead and let's make this a sheet metal part. So a quick process to create sheet metal in solid edge is just a quick transform. So again, it doesn't matter where it came from. It could be a Pro E, SolidWorks. We just say transform, and as you can see, it goes through. And now we have a tab feature and a couple of flange features. All right, you notice I'm missing a hole feature here because there is a hole in these two tabs, but it's being seen as a cylinder. So before I do anything else, let's create that as a hole. So I'm going to run a recognize hole command, and it's going to go ahead and find the two holes for me. It finds that they're 5/8 hole, and if I wanted to, I could change them on the fly, or I could just go ahead and say, you know what, that's fine, that's what I need. Now you notice that we actually have a hole feature in our Pathfinder. So just quickly, just taking a blank file and opening it up inside a solid edge, we can start creating some intelligent geometry. All right, so let's see how intelligent this geometry actually is. For this situation, I'm going to know these are going to be higher, these little tab flames on the side. So I'm going to go ahead and start grabbing these and dragging them up. But first thing I notice is that the holes in the middle are not associated with it. So, I can let live rules come pick this up, but that would require me to go ahead and make these concentric by moving the holes to match that. But we have relationships we can apply to this. So before I start dragging any of the features around, I'm going to go ahead and tell these features to go ahead and line up with the tabs. So it's just a matter of saying, you know what, I want this hole on the side to be concentric with that edge right there. Simple enough. It goes ahead and does it. Now when I grab this tab flange and start pulling it up, you notice it moves both holes. I didn't make both holes concentric. I just added a single relationship, as you can see on the side. I just created the one, but the one on the side closest to us is being picked up by a live rule. So it is finding concentricity, it's maintained in tangency, and it's finding symmetry about the XZ plane here. So when I drag these up, it automatically recognizes both sides, should move. I could go through and apply relationship to both sides. I can make the holes line up. Then I could just disregard live rules completely. But, live rules are there for a reason. They're a lot faster than me having to go make all these changes. So I'm going to go ahead and give this a little dimension here. There we go. That'll work for now. And of course, you know what? We actually need some more features. So this is going to be a base of the hinge. And I need some other features to attach to. So I'm going to go ahead and create a couple more holes here. And let's go ahead and make these same size as the other ones. So I'm going to go ahead and block my base reference plane. That way I can actually look straight down at it and go ahead and position this one. This one's easy enough to position because it happens to be centered on the coordinate system, which is really nice. The back two, you know what? I'm just going to go ahead and just randomly throw these on here. I'm not even going to align them up. I'll show you why. I'm going to go back and actually create a couple more relationships. I'm just going to go ahead and tell these two holes that I created to, let's go ahead and line these two up. So we're going to go ahead and line these two up. And a second relationship I'm going to add is go ahead and tell these two holes to line up to these holes. So I'm going to go ahead and do the exact same command. I'm going to tell those bottom holes to line up to that center hole there. And there we go, it lines up. So no matter what I do to this, it added a relationship here in the Pathfinder. So you can see that those will always stay lined up. So if this part stretches or gets shorter, those holes will stay with it. All right, let's take a look at these holes again. All right, so you notice from side to side, they're not centered right now. So before I throw a dimension on them, let's go ahead and center these up. We actually have a relationship for that as well. So I'm going to go ahead and tell this little cylinder here. So I'll grab that hole. And I'm going to go ahead and tell it to line up to this cylinder using the XZ plane. And you'll see it modified and moved a little bit there. So now it is centered. I can tell that quickly by just grabbing one of them and just quickly taking it and start dragging it around. There we go. And you notice what's happening there. It's moving the entire flange. The reason why is, again, that hole is lined up with the holes in the top flange, and thereby live rules is taking over and saying, yeah, everything's good. So I don't want to make it change. I'm just going to hit escape because I do know those are actually symmetric now. So let's go ahead and put a dimension between them. And let's see. Let's go ahead and just make that 4. There we go. So everything is nicely centered. Everything looks good there. A couple other things I need to do to it. So this is a fairly big part. and it probably needs some strengthening on it. I'm going to add some strengthening gussets on this guy, but what I'm going to do is actually add the gussets up and around this tab flange. Situation here is we do not have a unbend in synchronous. So, in a situation like this, I would go ahead and say, let's go ahead and create this in an ordered environment because we do have an unbend in there. So to get to the ordered environment, just a quick click, transition to ordered, changes my menu bars a little bit. Uh, Here's my unbend now. So I'm going to go over here and unbend these two tabs. That way I can actually create a flange around them. So I'm going to create a sketch on this. And let me go ahead and just do some includes. I'm just going to include these holes and offset them. That way I can position this symmetrically. Let's go 1/2 inch. And the same thing on these guys. That will work. And let's go ahead and just start connecting these. So I'm going to just quickly throw some lines off here in space. I'm not going to try to position them exactly, so I'm going to go ahead and trim these back, and I'll go ahead and also add some more geometry to the sketches. Let me go ahead and do the same thing on this side. There we go. All right, so just to get these all together, let's go ahead and just use some trim tools. So I'm just going to go ahead and trim these together. Same scenario on this side. Let's go ahead and trim these together. I've got some extra geometry in the middle. You know what? Let's go ahead and just trim these away. Don't really need these. And of course, I want these lines to be parallel with that. So as you noticed earlier when I did the relationships on the 3D models, well, obviously we would have the same type of relationships for 2D geometry. So I'm going to go ahead and tell the exact same. We have concentricity, tangency. This one I want to go ahead and say parallel because I want this edge, those two edges to be parallel all the time. So let's go ahead and create that. And you notice once I do that, my profile turns black. So right now I just undid one. So you notice it's blue. So basically it's telling me that this is not fully constrained, that this part can go ahead and move. So again, that's why it turned black as soon as I add that relationship to it. All right, and you know what? I'm going to actually add a bend radius on this. So I'm going to go ahead and fill up this corner here. And in doing so, it's actually going to, turn blue again based on the fact that I added another piece of geometry. So if I wanted to turn black again, I could quickly just add a 0.5 in there. And instead of doing it on both sides, let's go ahead and say, you know what, those are just equal. So again, my profile turns completely black. I know I'm set. So let's go ahead and close that out. Now let's go ahead and create that strengthening bead that goes across here. So we have a multitude of different types of deformation features, drawing cutouts. And here's the actual bead command that I want. And I'm just going to go ahead and use the default and grab that profile. And go ahead and point down into the object. And let me rotate that around so you can see what it looks like from both sides. That looks pretty good. Excuse me. And since, again, this was a bend part and I unbent it, well, let's go ahead and rebend it. So I'll go back to the rebend command. And it's just a matter of picking the two bends that I created earlier and go ahead and reselect those. And of course, you recognize the fact that the strengthening beads go ahead and go across the bends now. So we can pretty much add any deformation feature across a bend section like that. All right. Let me hide some sketches here to clean this up. All right, it looks pretty good. Let me go ahead and save this. Let me just call this base PSM. That's fine. All right, and for those looking at Solid Edge, we do have simulation. Depending on what level of Solid Edge you have, if you have the advanced package, you have the full-blown assembly simulation. If you have the basic package, you have part simulation. So let's just say in the situation you just have the part simulation. I'm going to go ahead and run a quick simulation on this. What I mean quick is very quick. I'm just going to do a couple face loads on this face and this face. Maybe, again, it's a hinge, so maybe it's hanging in this orientation, so we have some stress and pulling on those faces. Let's go ahead and do a new study. And before we can do anything, we have to tell it what type of material this is. So let's go ahead and apply steel. And what's nice about it is I can do multiple studies. I can do a new study and go ahead and make it out of aluminum, different types of materials, and run all the analysis in one shot, so I can get all my, find out what the best results are. And if we're in sheet metal, mid-plane surface is required. It's more accurate, so I'm going to just go ahead and say, let's go from inside or outside, that's fine. Let's go from the outside and finish that. And let's go ahead and turn off the design body. That way we can just see the mid surface. So now let's go ahead and define the surface that we're going to work with. And again, like I said, we're going to go ahead and say, let's apply a force on that face, 50 foot-pounds. And let's go ahead and do another force on this face, not that direction. Let's go ahead and swap that around. And we actually want it to be the same force. So let's say 50 foot-pounds in that. Go ahead and say, let's go ahead and fix this guy. Let me just say, this is a fixed face. And it's just now a matter of solving it. And this is the exact same solver that our big brother NX uses, and FEMAP. It uses the NX Nastran based solving tool. So it is a matter of that quick. All right, so we got our loads and forces on here, so we can just quickly animate that. Obviously, it's an exaggeration. It's about 10% over what it should be deflection. And once you're done with the, if you like everything, and if you want to send a customer a report, you can quickly create a report out of this. You can do it on the web page, or you can just use Word. I'm going to go ahead and just use Word to create this. And it is almost done, so that's it. So now I can drag through here, and you can see all the stress forces and all the faces, and it gives you actually pictures of the deformation. And obviously, you can save those pictures in different orientations. So that is a real quick way to get an analysis, get a first pass, see if it's going to actually work for you. So you know what, that looks okay with me for now. So I'm going to go ahead and turn the design body back on. That way we can do some other creations on here. Let me go ahead and kill my mid surface. Let me actually turn off some of the other things. Let me turn off the loads and the constraints so those don't get shown on the screen. So the next part I'm going to do is go ahead and save this, and let's go ahead and do the top part of this. There's a couple different ways to do it. We have the ability to create multi-body parts. I can go ahead and create a body in this part right here, where I can actually throw that into the assembly, create in place. In this scenario, let's go ahead and, since I'm already in the part, let's go ahead and just do an add body. And that way I can just create it in the context of this part. Then I go ahead and publish these out at a later date. All right, so let's go ahead and call this base. And let's go ahead and just call this simply enough top. Okay. All right, so as you notice, the part turns kind of an opaque color, which basically means I'm active into another part. And we're going to go ahead and create another piece of geometry above it. I'm not really concerned about exactly where it is above it, so I'm just going to go ahead and create a reference plane. Actually, there we go. And I don't know the exact height of it, so I'm just going to go ahead and drag this reference plane up to a higher level. So, oops, before I do that, I'm going to go ahead. I want to do this in synchronous. So I created that in ordered, actually. So let me go ahead and kill that. And let's transition to synchronous before I do that. All right. So I rolled my history tree back. By doing so, I just have the basis of the geometry. I don't have all the other features, which is fine because I really don't need them to create another part. All right. So here I'm going to go ahead and create my next plane. And again, I'm going to go ahead and just move that up above it. Look from the front view, let's say 4 inches. Just a good guess right now to say that's where we start. That's good enough. And since we're going to use make a part that's similar to this, let's go ahead and just do that by copying the geometry from the other part. So I'm just going to do what they call project to sketch and grab some of this geometry. And let's grab the outside edge over there. And I didn't get the outside edge. I got the inside edge. So make sure I get the outside edge. There we go. Get rid of this erroneous geometry. There we go. Now trim it together. So it's just a matter of using the same tools I used earlier to kind of snap those together. So there is a tab feature. And on this bottom part, I don't know if you saw the thickness I made it, but if I pull a dimension off of it, it's an 1/8 inch thick. So let's go ahead and do the same thing for this part. Let's go ahead and give it a 1/8 inch thickness. There we go. And let's go ahead and get these tabs created. So it's just a simple pull down, and let's go ahead and just say make these 2 inches. There you go. And look at the front view. All right, since the back side actually does line up. So again, I can use my synchronous tool, since I am in synchronous, to go ahead and just verify that by just grabbing the back face of this guy and start stretching it. You know what? I can immediately tell because the live rules kick in and these two faces move together. So that is an immediate reaction to being coplanar. All right, so I hit escape to get out of that. And you know what? These front faces, obviously, I can tell do not line up with the other hinge face. So I can just quickly grab that hinge face and let it start catching up. And as soon as it does, I'll be able to drag that out. And let me go ahead. I don't want that to be maintained. So I'm going to go ahead and say, you know what? Let's go ahead and grab key point here. There we go. Good enough. All right, again, since this is a square corner, let's go ahead and knock those off. So I'm just going to go ahead and use the round corner command in the synchronous environment. And let's go ahead and start moving this down. So obviously that's probably not tall enough, so I'm going to go ahead and stretch this down a little bit, maybe a ½ inch. There we go. And of course those don't line up completely, so I can just quickly just take this whole piece of geometry and move it on down. And to see, before I hit interference on the inside, let's go ahead and turn my shading off so I can kind of see where at what point we're getting close. Yeah, it looks pretty close right there. Let's go ahead and just pop that right there and turn the shading back on. I prefer to work in the shaded mode. All right, that looks fairly decent. All right, so we do have some holes on the bottom, and again, I want those on the top. I can go ahead and add, I can do a hole command, or I can do something a little trickier than that. Let me turn this reference plane off so it doesn't get in the way. Remember the include from sketch. Well, I'm going to come over here and let's do that exact same step. Include, include, include. So now I have my features there. Then it's just a matter of going ahead and grabbing these regions. And make sure I get all three. And just pull it on through. All right, since those are, again, just cutouts, I can just, remember, do the recognize holes. And it finds those holes. And again, it recognizes those at one time. So I'll just go ahead and say, you know what? Boom. Those are actual hole commands now. So there we go. All right. So the hinge looks pretty good. It lines up right there. Let's go ahead. Oops, I didn't get the other side. My mistake. And the fact that I didn't actually line up the other side. I might have not grabbed both sides. That is my mistake. Let me get the back side view here. Control K. There we go. Here, let me show you a trick here. Instead of having to come back and trying to recreate that, let me just go ahead and window and actually turn off the base. Grab that and just mirror that to the other side. There we go. Much quicker fix. There we go. And I'm going to go ahead and again and punch that hole through. Actually, I'm going to do a hole command on this time. And I'm going to go ahead and lock to a face here. So I can see that face. And just to show, we actually have something inside of ST6 now. It allows peer locate. Again, this works whether I'm creating plays or if I'm actually creating in the context of the part. Allows me to actually pick geometry and tie to it from other locations. It doesn't create a parametric link. It does give me the location of it. If I'm doing it in ordered, it will create that parametric link. So if I do change the other part, the part that I connected to will change as well. Let me go ahead and make a matching hole here. So that goes all the way through. That looks good. All right. So we're all looking good there. And I did the emboss on the, or excuse me, the drawn cutout on the other part, or excuse me, whatever it's called. It's called a strengthening bead. On this one, I'm going to go ahead and actually create an emboss feature. That's something also that's new to ST6 is the ability to create embossed geometry. So again, I'm going to go over here and say, you know what, add a body. But this time, I'm going to actually add a part body. And I'll just call this, the new body, I'll just call this emboss. Say OK. All right, so I'm creating a part this time. So I'm going to come over here and create a sketch. And we're going to let's just do an embossed text. Let's see, it's 1 inch tall. Let's give it some letter spacing, 0.25. And let's go ahead and give it a different font here. Just give it an Arial font. And all the fonts that you notice here are actually just loaded through Windows. So if you have a custom font that you would use, it would be actually in the list here. Let me block to this and rotate around and go ahead and position this kind of in the middle here. That's close enough. You know what? Let's make this a little bit larger of text. So I can quickly go back in there and say, let's make that 1.5 inch tall. That way, hopefully, I get all the emboss on there. It's with an 1/8 inch part thickness, that may be a little too close, but you know what? Only one way to find that. Let's go ahead and create it. So I'm going to go ahead and extrude that. And let's go ahead and pop it right there. That looks pretty good. So now, but I want to emboss this part. So what I'll have to do is, you notice I have my base, my top, my emboss. Well, I want to emboss it on the top, so I'm going to have to activate that part because that's the part I actually want to emboss with. So I'll reactivate that. It immediately takes me right back into my sheet metal parts. So here's my emboss. So here's the part that I want to emboss, and here's the part I want to emboss from. And you know what? I should have added some round to the actual top part there of the emboss, but I didn't. But you can see it's actually embossed there, so I can go ahead and turn that off, and now we have a hollow cavity on the inside. And I don't want to delete that because obviously that's being created from that. So I don't want that to show in the assembly. So if I go ahead and activate my emboss, I can go ahead and say toggle design construction. So I'm just going to go ahead and turn that into a construction geometry so it doesn't show up in the assembly. All right, so now that I'm done with that, I got my bottom part, I got my top part. We can transition back to ordered, and everything will pop in there nicely. So there's my deformation features and everything. So it's just a matter of now of coming back and saying, go ahead and multi-body publish. Oh, got to save it first. So it's saving. So there's my two parts, my top, my bottom. Of course, the emboss is a construction, so it doesn't get published. So I can go ahead and save my files. It's doing its thing right now. And since I saved that other one a while ago, I'm going to go ahead and actually, sorry, didn't mean to do that. Need to rename that. Sorry, yes. Rename base 2, since I already created the other one a while ago. There we go. So now say files. And they're all saved now, and of course it creates an assembly for me. So it's just a matter of coming back to my assembly, file open, takes me to my assembly with my part in the assembly now. Oops. Here we go. So I have my assembly copy, I have my two parts available, and that is what is new with Solid Edge ST6 with the deformation features and creating embossed geometry.